Hi and welcome to the Scientified Talk. Did you know your body has an incredible energy powerhouse that's often misunderstood? It's not carbs or protein, it's fat. Today we're uncovering how your body uses fat as energy and supports your health, and why it's the secret weapon for endurance and low-intensity exercise. Let's get started. Lipids are the sources of energy and can be stored in the body in a huge amount, as it is insoluble in water, and unlike carbs, high amounts can be stored in limited space. An average person can store 100,000 to 150,000 kilocalories of fat energy, 75 to 100 times the carb energy that one can store. Fats also insulate our bodies and protect the organs from injury. There are several types of fats, among which olive, canola, corn, safflower, and soybean oils are categorized as unsaturated fats. This means it is less likely to form a plaque in our body as they remain liquid at room temperature. For the body to function properly, an adequate amount of essential fats is required. Basically, high-fat diets are associated with the risk of cardiovascular disease and colon, prostate, and breast cancers. To avoid this, it is recommended to replace saturated fats with unsaturated fats such as omega-3, which decreases bad cholesterol in the body, and so it reduces the chance of heart diseases. In Mediterranean countries, where their food is rich in monounsaturated fat, such as olive oil and grains, fruits, and vegetables, the rate of people dying from heart disease is only half of that in the United States, according to the American Heart Association statistics. Omega-3 is largely found in the brain, as it seems that it is required for cognitive and behavioral functions. Lack of omega-3 during pregnancy increases the risk of vision and nerve problems. Lipids are used for energy production during prolonged exercise or extreme circumstances such as fasting or starvation, when carbohydrates are no longer available. Even small increases in using lipids during exercise slow down the consumption of muscle glycogen and blood glucose, and delay the onset of fatigue. Once the body breaks down the fats to produce energy, the parallel pathway to generate energy from carbs is blocked. So having fats in your meal makes your body stronger to endure the training. When the body is at rest or engaged in light activities, such as a leisurely walk, it relies predominantly on fat for energy. This is because fat is abundant and its oxidation provides a steady and prolonged energy supply. Imagine a fuel tank that never seems to run out. This is how fat serves the body during such times. Adipose tissue, the body's fat storage unit, quietly releases free fatty acids into the bloodstream through a process called lipolysis. These fatty acids, like tiny messengers, travel through the bloodstream, carried by the protein albumin, and arrive at muscle cells ready to be transformed into energy. At low exercise intensities, meaning at intensities of 25 to 65% of VO2 max, which is the maximal oxygen uptake, the availability of oxygen allows the body to effectively burn fat, making it the preferred fuel. This slow and steady release of energy ensures that the body can perform these low-intensity activities for hours without needing to tap into its limited carbohydrate reserves. But what happens as exercise becomes more intense? As exercise continues and the body's glycogen stores begin to diminish, a remarkable metabolic shift occurs. This transition from carbohydrate to fat metabolism is not abrupt but a gradual process, like a relay race where one fuel hands off the baton to the other. At first, carbohydrates dominate because they can be broken down quickly for energy. However, as time passes, the body recognizes the need to conserve glycogen for moments of higher intensity or emergencies. Fat metabolism steps in to take the lead. Triglycerides stored in adipose tissue are broken down, and the resulting free fatty acids provide the energy the body needs. This process slows the depletion of glycogen and helps delay fatigue, enabling the body to sustain activity for a longer period. The interplay between fat and carbohydrate metabolism is a testament to the body's ability to adapt to different energy demands seamlessly. But what about situations where high-intensity exercise demands immediate energy? When exercise becomes intense, such as during a sprint or a challenging uphill climb when VO2 max reaches more than 75%, the body faces a different set of challenges. the need for energy becomes urgent, and fat, despite its abundance, cannot meet the demand quickly enough. This is where carbohydrates take over, providing a faster source of energy that doesn't rely on oxygen. In these moments, fat metabolism slows down. The process of beta oxidation, which breaks down fatty acids, requires oxygen and time, both of which are in short supply during high-intensity activity. Additionally, the byproducts of carbohydrate metabolism, such as lactate, can interfere with fat oxidation. It's like fat steps back, knowing that carbohydrates are better suited for the high-speed energy race. This dynamic shift, known as the crossover effect, highlights the specialized roles of these two energy sources. So how can we train our bodies to make the most of fat metabolism during exercise? The human body is an adaptable machine, and regular endurance training profoundly changes how it uses fat for energy. Over time, muscles develop more mitochondria, the cellular powerhouses where energy is produced. These new mitochondria allow the muscles to burn fat more efficiently. Imagine a city building more power plants to meet its energy needs. This is how muscles adapt to endurance training. Alongside this, the enzymes that facilitate fat metabolism, such as carnitine palmitoyltransferase 1, become more active, speeding up converting fatty acids into usable energy. Capillaries in the muscles also multiply, improving blood flow and ensuring that fat is delivered more efficiently. With these adaptations, endurance athletes become better at sparing their glycogen stores and relying on fat for energy, allowing them to perform for hours without tiring. By understanding how fats function and making informed dietary choices, we can optimize energy use, protect our health, and enhance physical performance. If you liked the video, comment below, give us a thumbs up and subscribe. See you in the next one.